So anybody here heard of Revolution before? Again, kind of show of hands. A few people out there that have heard of this, or heard of who we were. So we were a provider of a distribution of Opensource R, Revolution R Open, which has some features in it that makes it run faster for certain types of workload, mathematically intensive workload basically. So we link the Opensource R project into Intel's math kernel library, and we make that available as a distribution for people to download from our website, freely available. You can do that for yourself as well, but it's quite a convoluted process, so we make it easier for people to get access to that. And by linking it into Intel's math kernel library, then anything people are doing in R that's a little bit mathematically intensive, like matrix, multiplication, etc., you'll get multi-threaded processing on that and more efficient processing. So it does speed up open source R processing. And then on top of that, the other thing that we provided was a commercial distribution of R, including that same kind of functionality, but also additional packages to make it easy for commercial organisations to adopt R and use it within their kind of enterprises. So two kind of core areas really, one around scalability, so being able to handle data set sizes potentially larger than memory, and doing again more parallel processing on those. And then deployment, which is kind of a fairly critical thing in the whole modelling phase of how do you actually get a model that you've developed into some kind of production context, so making some predictions with real life data. And you can see here Joseph Sarosh, who's the kind of CVP for analytics within Microsoft, who's the sponsor of the acquisition. Really sees this as a kind of key benefit to Microsoft in terms of bringing Revolution on board and the integration back into the Microsoft product set. So who am I? Because I'm not Andre. So my background is working in kind of data architecture, various MPP databases, lots of kind of ETL and data managing type projects, those kind of things, before I joined Revolution. I haven't got a huge amount in the way of advanced analytics. Most of what I've done in terms of advanced analytics or predictive analytics for customers was around how do I get data into the right shape so a data scientist can do something with it. Because generally, data scientists want to see their data in a particular way in order to run models on it. So that was a lot of what I did for a living before I joined Revolution. The thing we're going to kind of talk about is the current situation, and then I'll show you some demos of some new functionality we've got coming, which is going to really help with using R processing alongside and inside SQL Server. So obviously SQL Server, very, very popular database out there. One of the most widely used SQL databases. R is now I think probably the most widely used statistical programming language. You see various surveys out there for its use, and it's grown very, very quickly. And in fact, in the language ratings in terms of popularity against other languages, just general purpose languages, you now see R up in the top 10 of languages. So kind of, how many of you here have heard of R, first of all? I guess would be interesting to... Okay, and I know there's been some sessions earlier this morning I've not been in, so hopefully I'm not repeating too much. And how many of you actually have used R within your workplace or personally? Good stuff. Yeah, great. So using R and SQL together, and this is kind of traditional way that analytics has been done, is you have to extract the data out of the database, and then do some manipulation on the data typically, and store it somewhere, not necessarily in a database, and then process it, having extracted it. So there's a whole bunch of processing that goes on to do that, not always the most efficient in terms of data flow. And it kind of breaks away from the whole philosophy of keeping data in a database where it can be maintained and looked after, etc. And what we're doing with the new functionality that's coming out in SQL Server 2016 is providing some capability to do something a bit different, which I'll show you later on. So I will probably, given the number of people that know about R, I will probably skip through the slides just giving an overview of R. I suspect that some of the previous speakers on R have already covered some of this as well. I'll talk a little bit about what Microsoft is doing with data science in kind of the cloud or Azure, Microsoft Cloud Services, how you can connect R to SQL, and I've got a demo for that, how Revolution's engine works, if you were to pull some data or have some data in a file you wanted to work with, and then I'll show you how we combine those two things so that we can work in a database in SQL Server. And then how would you go and take that and deploy it either on a production server or in the cloud. So, talked to this a little bit already. So R is being very, very heavily used now. There's a lot of universities that teach it as the kind of default programming language for stats courses and statistical computing. And as a result, what we're seeing is a lot of people coming into the marketplace, job market, with those kind of skills, as opposed to in the past, maybe they would come into the marketplace with SPSS skills or MATLAB or SAS, for example. So one of the reasons for its growth is because it's open source, people can extend the functionality of R. And there's a package repository called CRAM, which has over 7,000 packages in it. Now, how do you navigate around that? Actually, probably a lot of those packages are very esoteric or very specific to a particular problem. And there are various ways that that has been categorized and make it easier for people to search and find a particular model or a particular piece of functionality they need. But the packages don't just include analytical functionality, they'll include things like various types of connector to be able to read different data sources. So for example, if you work in financial services, being able to read directly from Bloomberg feed, market data, and then you can work with that in terms of predicting the markets. And again, other packages for doing that kind of thing. Data manipulation packages. And I guess probably the most popular is a lot around visualization. So the reason you see R's growing popularity is that a lot of organisations are using it to produce some really nice graphical visualizations of their data. And in fact, a number of kind of big publications like the New York Times and The Economist make use of R in their publications. So that's how they generate the graphs and statistics and the information that they use within their publications. So a brief history of R. It's originated in New Zealand with a couple of lecturers basically wanting to create a language that they could use to teach statistical computing to their students, and finding that all the other languages that were out there at the time were commercial and not wanting to pay the license fee, they invented one themselves and open sourced it. And it was based on a commercial language called S++. Went through a number of different iterations, and around 2000 kind of really went mainstream, and it's been growing ever since. So the package growth since I joined Revolution 2.5–3 years ago has gone from 3,500 packages to 7,000 packages. So that gives you an idea of the number of people that are out there who are using it for their research, for their university studies. And again, another reason why universities like it is that if you need to prove theorem as part of your degree course or your PhD, then you can write the code to prove that and publish it, and then other people can go and test it and evaluate it. So it's very well tested in the kind of statistical math community. Mentioned some of the visualizations. Here's just some examples of that have been generated with R. So this kind of map heat plot is an election forecast that was generated by the New York Times. And here you can see other kinds of, this is NFL football, various different ways of looking at the data, and all of these are available for free as kind of different graphing capabilities within and packages within open source R. Here's a kind of example of how you navigate around all of those different packages and try and understand which ones might be useful to something you're trying to do. It's apologies if it's a bit difficult for you to see this at the back of the room. This is something called CRAM task views. So it's where different people look after certain categories and look at packages that are coming into CRAM and maintain a list of, well, these are the kind of packages that might be useful as a starting point, and then you can go out from there. One of the difficulties with R is it's a single letter, so if you try and search on it in Google, looking for something, you may not get something terribly useful back. There is a dedicated search engine that extends Google called RSeek, which you can use, which will help you to find packages. So it kind of knows to just look and reference things that are in the R community as opposed to looking more broadly. So you don't return lots of registered trademark, for example. So yeah, here's one, machine learning and statistical learning. So if you wanted to do something in machine learning and statistical learning, you go to that task view, pull it up, and then you get a bit of a description about what machine learning and statistical learning is, and some of the different packages in there with links through to those. And if you go to our website, we also maintain a really nice graphical HTML view of this, which you can drill down and search on. Okay, so let's talk a little bit about data science in the cloud with Azure. So kind of trends that we were seeing before we came into Microsoft is obviously a lot of people talk around data explosion. So phones and various devices now generating data, and that data being accessible, generally coming straight into the cloud to be processed there. It's publicly available data, some of them, things like Facebook, those kind of places. So geolocation data, and the fact that you sign up to services which then allow people to potentially market to you based on what you're doing. And there's obviously a lot of predictive requirement and capability in there. And because of the data volume growth, I think cloud computing has really come to the fore now. So 3 years ago when we first started talking to customers about Revolution and doing stuff with R, nobody wanted to do it in the cloud because they were worried about data privacy and those kind of issues. And now I would say that sort of 30-40% of the customers we talk to have got some kind of cloud strategy in their IT organisation and are looking at, okay, what data can we process and do in the cloud, and got some kind of roadmap as to how we are going to move the cloud. Talk about the data science talent gap. So really, the big issue is because there's so much predictive analytic requirement out there now, people want to do that kind of analysis in business. There's a real challenge trying to find people with the right skills to be able to do that. And given the teaching of R in universities, it's kind of a natural match that as these people come out of university, we can start making use of them without having to cross-train them into something else. This is kind of interesting. So I won't dwell on it too far, but you can see that kind of software revenue has kind of generally, new license revenue has generally declined. But now with cloud subscriptions, license revenue has kind of stabilised. But generally, there's a process of people moving to a more subscription-based model in the cloud. And I'll show you that later on that Revolution now runs inside Azure's cloud services. Okay. So prior to the Revolution acquisition, there's a product that Microsoft had created, which you might be familiar with already, Azure Machine Learning. This is the Workbench, which allows you to develop kind of data mining workflows, data processing, data mining workflows as an end user. And I think one of the interesting things is this has, for a long time, this has had the ability to execute and run an R script within it. So you can pass some data in it from one of these data flows. Here you can see a little bit of our code that somebody's copied and pasted into there. And then this is going to run based on data that's being fed into it. So you can read from these inputs, these data inputs, so that will appear as a data frame within Azure. You can do some pre-processing on it using R, which extends the functionality of Azure ML to things that it might not already have the capability to do. So you get the full power of the R programming language within Azure. And then you can then output that to something else, to a file or into another part of the Azure ML toolset to process the models on, etc. So it really makes it very, very extensible. One of the things that we're doing as part of the integration is the Revolution R functions that I'll talk a little bit about as we go through. Are going to get embedded in here as well, so you'll be able to make use of the scalable functions we provide for faster processing and working with bigger data sets. Those functions also give you the ability to process in SQL Server inside Hadoop. So given that you can also run those kind services within Azure, then there's natural integration that will be there through the inclusion of those capabilities in the product. So this is kind of, again, just looking at what R can be used for. This was a genomics study looking at people's propensity for certain disease types. You can see a list of disease types along the bottom, and it's a heat map. So I guess this is probably heavy warning, whereas the blue is low risk. And Joseph Sirosh, the CVP that I mentioned earlier, so this was running on a Hadoop cluster, the processing for this inside Azure. So Joseph had his genes swapped and submitted that through cloud and presentation to do a predictive service against that data in the cloud, and then proactively on his phone, as you can see here, get some indicators as to what his genetic risks are for certain disease types or propensity is for certain disease types. Those are the kind of services you can run by having this stuff in the cloud. So probably not relevant to your immediate businesses, but certainly being able to run predictions in the cloud that you've built models on, either in your own organizations or if you've built those out in the cloud as well. Okay, so let's talk a little bit about connecting R to SQL. So I mentioned Revolution R Open. So that's the open source product that we have that includes this linkage into Intel's math kernel library. We also have a focus in the product on reproducibility. So we've developed some packages which you can again download and use. So Checkpoint being one of those. That allows you to rerun or to run code as of a particular point in time, effectively. So one of the problems you've got with packages constantly evolving in CRAM is obviously their version numbers change. You might run a piece of statistical research this year, and you might want to rerun that research next year and want to be assured you're going to get the same result if you put the same data into it. Checkpoint allows you to do that, so it will basically version control all the different packages you're using within your code to make sure that you run as of that point in time that you ran the previous one. And you can checkpoint to a different point in time as well, so you can sort of go forward or back through a series of packages. Okay, so hopefully the demo is going to work. What I'll show you first is just using ODBC to connect to R, and if you're doing this using kind of open source R, so let me put up R Studio. How many people are familiar with this tool? R Studio. Okay, so we've got a few people that have used it before. So this is a company, R Studio, that developed a really nice IDE, development environment for writing and executing R code. There's a free version which you can download, run on your desktop, and there's also a pro version which you can pay support for. The free version is very, very good. I use it quite a lot, free demos. Revolution already has, we have an IDE as well, which we include in our product, based on Visual Studio, and that's receiving some enhancements now again as part of the integration into Microsoft. So some R code here on the left-hand side, and a number of scripts which will run through the presentation. Down the bottom here, you'll see code that's running, the output of code that's running. In here, in the environment, you'll see various objects that we're creating, like variables effectively that we're defining as we step through the code. And over here, you'll see, in fact, this is the result of plotting in one of my scripts. So you'll see something similar to this appear in a second. So if I want to pull in some open source packages to use in my script, I use this library function. If I've installed this package already, if I want to install a package, I can go here, tools, install packages, and then type in the package name, and it will do all the installation work for me under R so that code is available. I've installed these already. So you can see as I step through, down here it's just running it and pulling that library and making it accessible. So the first thing I need to do if I want to connect to SQL is to set up some connection string, yeah? So I can actually connect to the database, and that's what this code here does. on this. And kind of weirdly, for some programmers out there, the assignment operator in R is this symbol here. So basically this is saying that SQL host is a variable that's going to get this value here, which is a string, obviously. That bit. I need to define a query that I want to run against the database. And then can run that. So this will take a few seconds to run. And what it's going to return, so this is a function, and this function takes some arguments, and the arguments are the things that I set up here previously, so my database handle, my connection string, and the query that we defined. And what it's going to return, the output of this function is a data frame. So a data frame in R is an in-memory structure that looks like a table to database people. So columns, different data types potentially, and a whole bunch of rows. So what did we return there? Well, 600,000 rows of data. I can do, so the package Magritar that I pulled in, the library Magritar, allows me to pipe something into another function. So it's quite a nice way of coding. It's a fairly new thing in R. Again, this is this extensibility that the community generates these nice new features. So if I pipe the data frame, so the actual data, into the function head, then it returns me the first few rows of the data. So anybody that's used Linux out there, a lot of the functions in R have a similar naming to Linux equivalent functions. And we can see what our data looks like. So this is airline data of arrival delays by departure times by day of week. And let's run this. We can get some kind of idea of the structure of the data as well, so I can see how that looks in the data here, kind of from a data frame perspective. So I've got some integer data, some numeric data, and I've got something that R calls a factor, or categorical variable. So I've got various values, 7 levels, one for each day of the week, and then I've got an indicator here as to which day of the week it is in the data. So it's an efficient way of storing this kind of data where I don't have to actually store the character values in the column itself, and just store that in the metadata. Right, so I'm just going to define some factor names, and then I'm going to run an actual linear model. So this is a linear regression. Here you can see R has like a formula interface, so for defining the statistical formula that I want to run as part of my model. And I've got here that I want to look at arrival delay by departure time and day of week, to see if I can understand if there's some kind of correlation or related to that data. And then I can get, so that ran a linear model, and it's put the linear model object in model.lm, and now I can get a summary of that. A bit difficult to see with the reduced screen size, so I had to go on the screen here, but you can see here that I've got some model object output, and I can see my residuals and coefficients for this linear model. And if I wanted to plot that, down here I've got pulling up in another package. OF plot, I can do a coefficient plot of that, and you can see over here by day of week different coefficient values, and I can get some idea of what my data looks like, what my model looks like. Okay, so that's how I would do things with Opensource R, and in a few minutes I'll show you how to do the same sort of thing using ReboScale R, and then I'll show you how you can do the same thing in database. So Revolution R Enterprise, the product that I'll show you some functions from next, basically is another package, which includes a whole bunch of functions. So you've seen how I, using the library, I pulled in a package. So, with Revolution, we have a package called scalar, and in scalar, it contains a whole bunch of different kind of algorithms or functions for working and processing data at scale. So one of the challenges of using Opensource R is that Your data needs to be in a data frame in memory, so you've got to pull the table or the data that you need for your model into memory in R in order to be able to run your processing on it, which might be okay for most of the kind of data volumes you deal with on a day-to-day basis, but you might find that actually some of the data volumes are too big to put into the memory of the workstation that you're using or the server that you're running. So the first thing is that Revolution R functions allow you to work from data that's sat in a file or some other data source. And we read data in chunks and we process and build the model on data in chunks. So we don't have to have the whole thing in memory in order to be able to get that model out. And then the second thing that we do is because we're reading the data in chunks, we can actually pass those chunks for processing independently across whatever the number of cores are on the machine that we're running on. So I can now parallelize my processing on a single server, on a cluster of servers, and in different database technologies like Teradata, SQL Server, the kind of big data processing technologies. And you can see here kind of categorized by type, the sorts of things you can do. These are all fairly standard modeling statistical algorithms that you might want to run on your data. But it's a subset, to be clear, of the total amount of statistical functions that are available, obviously, in those 7,000 packages in CRAM. Right, so let's flip back to RStudio and go to this other script here. So this is the RevoScale R script. And let's clear the screen down here. So here again, I'm going to set up some day names. What I've done is I've pulled that data from the database into a CSV file called airdata.csv that's in my file system. And I'm going to read that data in, and I'm going to convert it into XDF file format. So that's a Revolution specific file format. Stands for external data frame. I could work directly off of this CSV file if I wanted to and build my models off of that. It's not going to be as fast if I'm doing a lot of work with it. So it's more efficient to take the hit to convert it into an R XDF file format first and then work with it from that XDF file format. I'm going to be working on it a lot and doing a lot of iterations over the data. Let's just step through this. So that just defines object, text data object, RX text data in air.csv, and then I'm going to do the same thing and effectively write it out to an XDF. So find an XDF file format, and then oh yeah, thank you. I missed part of the code up here. Thank you. Wasn't really looking at the screen. Right. So what we've done is we've passed that data in from CSV format. We gave it some idea of the definition of the data, so how to interpret what it was reading from a data type perspective. And then we've written it out to this out file, which we've called XDF as the file name object. Revolution has this concept of compute context, so I can set a compute context of local parallel that's going to make use of all the cores on my machine. I can use local sequential as well, just run it as a single threaded process. And you'll see in a bit that we can also now set a SQL Server compute context to do the processing inside SQL Server. The code generally is going to stay the same. It's the compute context that changes, and I can flip backwards and forwards between working locally with some data I might have in a file or in a data frame to working with data in a database. And so if I've got big data in the database, I can maybe develop the model on a sample of data on my local machine and then push the code into production inside SQL Server by changing this compute context. So let's just go and have a little look at what that data looks like. So if I look at the file, I can see it's the same 600,000 rows, 3 variables. It's stored in 6 blocks. So we're going to read it in those 6 blocks in chunks. Again, I can go and see what the variables look like. the actual XDF object, so I can also define this XDF object that we've created as a particular object type to R, and then it knows a little bit more about what to do with it rather than just as a text string. So for example, I can use the nrow function on that now. I can use the head function and various other things to actually see what the data looks like, how much data I've got, etc. And if we look at the object itself, this XDF object that we've created that we're going to use for our models, executing our models, it's really, really small. It's basically a pointer to the file, okay, on disk, so we've not put that data in memory. But if I go and look at the file out on disk, you can see it's not huge, but you can see it's a number of bytes inside, much bigger inside, out on disk. So I've just run a summary function on the data to get some idea of what it looks like. So here we can see kind of counts for the days a week. I can see kind of days of week have certain categories of factors, and I can get some idea of what my kind of distribution and my statistical values are across various numeric columns. And if I wanted to run a linear model on that data, I can do that. It's going to run in chunks, so you can see it's very, very quick, even though it's working off of disk now rather than data in memory. And we've processed each chunk without having to have the whole thing in memory at once. But basically run the same kind of model that we had previously using the ln function. And if I go and look at the output of that, we can see that actually it produced the same result, regardless of the fact that now it's using the Revolution function, working from disk rather than RAM. And again, if I want to just plot the output of that. And I get the same plot. So exactly the same statistical output that I got previously, but now I've not had to have all the data in memory. It means I could work with a much, much larger file if I wanted to. We've got customers that have got XDF files of tens and tens of gigabytes on their local file system, and they're using those for processing, which they couldn't do with data in memory, obviously. Okay, back to the presentation. So, we talked a little bit about this already, but the challenge of traditional analytic approaches is this one that we've just shown you, where I need to pull some data somehow, whether that's dumping a CSV file or directly connecting to the database, pull some data out, put that in a local file system to work with. This ends up being very, very large, like I talked about, so it becomes a data management issue in its own right. End users end up building their own ETL in the background in order to get data out and maintain data in this thing because they've got specific views of the data that they want. All of those things could be served better from using a database directly, potentially, if you could do the processing in the database. And so that's the aim of this new functionality that's coming in SQL Server, is we really want to push this, or leave this data in the database as much as possible and do the processing actually in the database server, not here in the analytics server. The analytics server just becomes like a client tool to do processing in the database server, like a more traditional BI tool. So the way that works is we've built integration that allows you to access in a couple of different ways. So you can either, as you'll see, run an R script, connect and run your processing in the database, or you can execute it via a stored procedure as well. So if you wanted to build some production functionality around stored procedures and then accessing those stored procedures from other tools or applications, then you can do that. You can run the R code directly within the stored procedure rather than having to control and drive it from an R script. And the way it works is there's kind of user-defined table functions in SQL Server, stored procedures in SQL Server that will call out and pass data into the R process running on the SQL Server server. And we handle the data interchange automatically so everything stays within the same server, as you'll see in a minute. So data scientists can interact directly with the data through an R script, and developers can, once that model has been created and you've got some prediction function that you've maybe built in an R script, you can save that into the database and then make use of it as a prediction directly on the data. And of course, the database you might be doing that on could be a completely different database. Okay? It's the same code, but if you've got that operational data in a different database, you could do your prediction and scoring on your operational database, and then have your users doing some work on their analytic data warehouse. Mouse control. Okay, so this is the final R script that shows running in database. So similarly to the way that we worked before, we need to set up a connection string. I'm reading in my password here from a RDS file. That's an R data set. I've saved it away so I don't have to show my password or keep it maintained in the script. Obviously that could be just secured so that only this user can read it. Set up my database connection. So the thing that we do now that's slightly different to this code you saw before is instead of using RX text data as my definition of the data that I'm going to read, or even an XDF file if I've created an XDF file object, I can now define a SQL Server data source. And this is the data that's going to get used as input into this particular piece of R processing. And similarly to the code that you saw before, I'm setting up here what does that data look like so that R knows how to handle it as it reads into the process. Okay. I mentioned compute contexts earlier, so we saw the local parallel compute context. So this is a new function that we provide now, or we will provide in this 2016 release. So we now say RX in SQL Server, which is basically saying, from this point on, every time I see an RX function, I want you to go and instead of running that locally on the local machine, work out how to package that up, ship it into the database, execute it in the database, and just return the result set or the output of that function back to my R console. So here we have that same modeling function that we had before, the RX linmod function for running a linear model. I'm going to execute that. Now you'll see this takes, I think, somewhere in the order of 30 seconds to execute. So this is the pre-release software at the moment, so it's still not fully baked out from a performance perspective. It's fully functional, but we're working on some of the kind of performance enhancements to this. But it's the same data set. In fact, you can see here 600,000 rows processed, so this is just the console output. I could have set that to false, so I don't have to see this down here if I don't want it cluttering up my console, but it's quite useful if you're running a big process to be able to see what it's done. If I take a look at that, again, same data, but now in a different area, different data source, produces exactly the same analytic output. So we've worked out how to generate the right equivalent processing to run inside the database engine itself. And likewise, just do the code plot on it. You'll get exactly the same output over here. So, any questions on that? At this point, I'm going to show you how the stored procedure works as well, if you want to use that. Yeah.
Just one. On when you run it off the text file, you're doing a bunch of people doing a bunch of 11,000, and then when you just do it on the server, it's 5,000 and then the second.
Yeah, I've got the chunks. Yeah.
What's the control?
Yeah, so you can set that up in your compute context. Sorry, not in your compute context, in your data source definition. So when you create the XDF file, you tell it how big you want the blocks to be. You can read in multiples of those blocks. Then, when you are using the file, you can't read less than a block. So we'll do efficient read if you say I want to read 5 at a time because I know that I can get 5 in memory. And for this particular process, it works well. But yeah, you can't read smaller than an individual block. So the recommendation normally is to use a modest block size because you can always go bigger, but you can't go smaller. And the same thing in SQL Server. So in SQL Server, we're just saying how many rows at a time am I going to read and then pass into the process for processing. But if I had a particularly memory-intensive process that I was running, a model, then I could reduce the number of rows that I was reading in order to reduce the memory stack. Yes, sir?
The RX SQL Server data objects, you specify the table. Can you specify a query with that?
Yes, you can. Yeah, exactly. So you can either put SQL in there, or if you just want to, yeah, thank you. If you just want to read the whole table like we did there, then I can just specify the whole table name. So the SQL statement, and I've done this, so obviously this functionality is pretty new. We also support running in database in Teradata inside Hadoop. I've put some pretty complex SQL manipulation within the SQL statement that then gets passed into the model processing. So that's quite a nice way of working, because you can use SQL to do your data transformation, some of your heavy lifting, your aggregation, grouping, and then you can then pass that directly straight into the modeling function without having to pre-compute it and create a table that contains that output. If you don't want to. And it works off of views as well. So if you want to define that logic in a view and then query the view, you can do that as well. Okay. So let me just flick to. Okay. So. So you guys can see it rather than just me. Okay. So in here I've got. So this is how you could execute some R code within a stored procedure. So you can see that we specify the language as R, and then the code that we want to run. This very, very simplistic R script in this case. So I'm just taking the input data set and typing it straight to the output data set, so it's not actually doing anything. And my input data set is this query here, which is basically just repeating on one. So let me just run that. Oh, obviously don't quite like actual code one. So, predictably returns 1, okay? But you can get the general idea of what you can do. Something a little bit more sophisticated. So here, one of the inbuilt data sets, apologies for the pagination here, it's a bit difficult for you guys to see. One of the inbuilt data sets in R that you can use for playing around with. So R comes with a whole bunch of inbuilt data objects that you can use to test code out and play around with without having to reading your own data. Is something called Iris, and the Iris data set is quite popular and used in a lot of different modeling functions as examples of the company you can run. So here what we're doing is we're just pulling back data from the Iris data object and then returning it. From that. Okay, so here I've got the output of that particular data object. There's an extra column in there that I've dropped off, so the code is doing something a little bit more sophisticated than a straight pass through. So I just said select everything other than species. But this R code in here could be as complex as you want it to be. So it could be reading in a data frame, could be reading in a record that you want to run a prediction or a score on, using a model object that you've already got saved in R, and then outputting that into another table. So you could write this out to the table, so you get your predictions and your scores directly in the database. Okay. Any questions on that? Okay, so various different ways of working in terms of generating a model using various kind of modeling functions like LM or RxLinMod, like you've seen. Generally what you're going to do is run your model, build your model object, and then you're going to want to run some kind of prediction on it using a predict function or RxPredict if you're using Revolution's functionality. And what we're kind of supporting here going forward is you can obviously work on a sample of data locally on your local machine, and you can store that using R as well, in the same way as you've always done. You could pull a sample of data, you could be working in R, developing and building your model, but then you could actually use the store procedure functionality if you wanted to. You can store that in SQL Server itself. You can model in SQL Server using Revolution R, so actually develop the model in R, like we saw in the third and final R demo, where we were doing the processing directly in SQL Server itself, and then you go and store it there. And we also support now the ability to take some R code or model prediction effectively created and store that within Azure ML. So build a web service that's a scoring web service. So if you've got very high volume requirements and you want something that's an always up service, always there and resilient, you could actually publish through some functions that would provide a model into Azure ML, and then that gives you a web services endpoint that you can then interact with from your application to actually do your scoring at high transaction volume. So I mentioned earlier that Revolution R is now available also in Azure's marketplace. So if you guys have used Azure, I don't know, but you can go and create a virtual machine which comes pre-installed with Revolution R Enterprise. There's a 30-day free trial on the software. So if you wanted to get started up for next to nothing. And the actual smallest VM is pretty low cost anyway, so if you just wanted to play around with the software, you get an idea of how to use it. And then going forward, once the SQL Server capability is released, we will have SQL Server images also available out there as well. So the functionality that you've seen running, which requires a Revolution client, i.e. my machine here, interacting with a SQL Server database. I could set that all up in Azure, so I have my SQL Server database with RRE installed on it. And then I will have my Revolution R Enterprise desktop for server in the cloud that I can run my processing. Okay. Any other questions? That's kind of all I've got to cover. Does this look interesting, new functionality? It's going to be part of SQL Server 2016, so Enterprise Edition, so you'll get it, I think, pretty much baked in free of charge. Yeah.
So you say baked in, but do you have to have Revolution R clients to use that?
Yeah, but that will be made available on Workstation through MSDN, so if you've got MSDN subscription, then you'll be able to pull down the Workstation edition.
The subset of packages are those the only ones where you've got that sort of SQL connectivity. And then other ways accessing wider range of packages.
Yeah, so in store procedure, you can create and run any open source function in there. Bear in mind, though, that what it's going to be doing is creating a data set and a data frame out of the SQL that it's running and then passing it through. So you'll have the same potential memory limitations there, but it's running on a SQL Server, so it should be more efficient. You're not going to physically move the data. There is a way with the Revolution functions, there's a function called rxexec, which will wrap and then run any other open source R function. And you can run that in parallel as well. But you need to think a little bit carefully around, does it make sense to run this function in parallel? So for example, if I want to run it 8 ways parallel, it's going to basically run me 8 linear models on potentially 8 subsets of the data. That might make sense because I have a many models problem that I'm trying to compute. But if actually what I was trying to achieve was running 8 ways parallel on a big data set in chunks, then those open source functions aren't aware of how to kind of split and divide and parallelize their processing. That's what the Revolution R functions do. So they're designed specifically to work with data in chunks and process in parallel without you having to think about how do I take this mathematical algorithm and break it down to run it in parallel. Okay.